Folks, the end of day one of our conference adventure is rapidly approaching and can be seen on the horizon. But fear not, we still have time for a few more top tech talks, and our next one is pretty amazing for sheer ambition alone. Your next speaker of the 2021 CityJS conference is Brian from Vancouver in Canada. Brian is the CEO of Begin, a service which aims to make serverless effortless, and I promise you that is quite a tongue twister. In this talk, Brian is going to be guiding us through the 300 plus AWS services that are available for us to use to make serverless applications. But unless you know where to start and what it is you need before you start, chances are you're just going to end up confused. And impressively, in this talk, Brian is going to build an application in 1 minute. So please have your stopwatches at the ready, because I will be thinking up a suitable forfeit in case he doesn't make it in on time. Trust me, I will be timing. If you have any questions for Brian after this talk, please join us for the Q&A session, which will be starting on GatherTown immediately afterwards. And keep those posts rolling in on social media using the hashtag CityJS2021, as well as in the comment sections or wherever it is you are watching along. Brian, it is my pleasure to hand the conference stage over to you.
All right. We're here, live on the internet. I'm very excited to be here. Thank you so much to the JS organizers. Organizing during a pandemic is no fun. Live event, it's pretty tough, and honestly, it's been really great working with you all. And thank you to attendees for letting me take half an hour of your time. Original title of this talk was Welcome to the Fast Stack. And Fast Stack stands for Functions, APIs, Storage, and Testing. And this is how I'm thinking about building apps these days, but I realize that this is proposing a solution without talking about the problem. And we do this all the time as developers. You know, if someone asks you how do you build a website, you're probably going to respond immediately with your favorite framework before you even dig into what problem they're trying to solve, which might not be appropriate for that framework. So I decided I would take this talk to really share with you how I think about building websites from a backend perspective. And this is going to come from first principles. We're going to go all the way from the very beginning and talk about what the solutions are to these problems. It's one of my favorite quotes: the chief cause of problems is solutions. And it's true when you think about it. Eric Seviard was probably not thinking about web development, but it's kind of true, you know, like whenever you look at your app and you think, wow, that's a huge problem, that problem is downstream of a former solution. And the way we solve this is to keep things simple. We want to break things down into the smallest constituent, tiny little pieces, the most discrete little bits, and do nothing other than just solve our problem and work from first principles. And so this is what we're going to try and do today. One last quote, I won't do this all talk. I love this one. Given 1 hour to save the world, I would spend 55 minutes to find the problem, 5 minutes finding the solution. Albert Einstein. And I think this is a great way to think about how we approach our work, and maybe to not jump to the solution, but start with the problem that we're solving. Okay, so problem number one is web hosting. This is usually something that we kind of get to gloss over a little bit as front-end developers. Sometimes we don't even have a say in this part of the world, but it doesn't really matter what vendor you choose. This will be a source of problems down the road. Building web apps is tough. Deploying them is very tough. And each host has its own special attributes that can be challenging. Now, for my time, the easy answer here, or the right answer, is just use AWS. And you'll hear people say just use X all the time, but I think AWS has some compelling arguments for it. So first of all, they are the incumbent. They are the default that you need to remove from the list. They are the starting point. They are the de facto pioneer and leader of the entire cloud market. It's not a question of whether or not you should use AWS. You really have to ask yourself why you wouldn't use AWS. They are very stable. They don't ship breaking changes ever. This is pretty famous. You can see in the S3 API, there's some vestiges of 15 years ago when they first launched. And that's a huge feature. The other clouds do ship breaking changes, which is a nice way of saying they will invite unplanned work. So this is something I think doesn't get enough attention and should. With AWS, you've got a really stable base. They got good value. A lot of their services are on demand and have huge free tiers. So you can do a lot of work without having to pay anything upfront necessarily. And you only pay for what you use, which is nice. And honestly, some of the best customer support I've ever had. They will pick up that phone, they will answer the email, and they will help you until you're satisfied. It's very rare. A lot of companies will say they're customer friendly, but when the metal hits the road, that's not always the case. So AWS is the boring choice. They are the largest vendor with the most capabilities. They're not going away. They make plenty of money. They are very stable and again, good value for what they do. This solution does come with some problems. Like I mentioned earlier, by adopting AWS, we've adopted the problems of AWS, and there are a couple pretty big AWS problems. AWS is just hard, but hard isn't specific. So like, what is hard? Let's unpack that. So first thing about AWS is vast, it's very big. There's 270 services, and there's new capabilities every week. And that's a lot of stuff to navigate. And to try and parse all that stuff is a job unto itself. There's whole companies and analysts and consultancies that do that. And AWS has a very famous thing where they've got two pizza teams. There's teams of people that can be fed with two pizzas. And it's true. They actually do have lots of two pizza teams. And the consequence of this is that there's lots of services and there's lots of overlap and there's a lot of complexity that comes with that. They're trading consistency effectively for velocity. And we're going to dig into each of these one by one. So let's start digging into AWS's vast. If we're going to solve that problem, we're going to eat that elephant one bite at a time. So, you know, even if we're just talking about databases at AWS, we've got MySQL, you got Postgres, Cassandra, Mongo, DynamoDB, the list just keeps going on and on and on, and they're adding more every day. And if we're talking about compute, you know, they've got EC2, they got Beanstalk, Lightsail, Fargate, EKS, and then that upstart Lambda. So the first place I'm going to start is from the idea that I want to be building things that are on demand, and I only pay for what I use. And that kind of drives me towards Lambda. That's the primitive for that. I think Lambda is a very compelling choice for your compute workloads. It's stateless by default. You are billed by the millisecond, which is a profound change from how we're used to be, that uptime was a good thing. And you wanted to have your server up for a long time. In the Lambda world, we don't want uptime. We want that thing to go away after we're done the work because we're only paying for what we use. The big change here too is that the unit of deployment is a function, and that's profound. Why do we talk about servers if we're not deploying physical servers anymore? You know, when a millennial sees a floppy disk and it says save, it's kind of what a server is like now. It doesn't really make as much sense. It's an old metaphor that doesn't really serve us. But you know, we got to unpack this further. Like, why would we choose Lambda? Like, what are the reasons to choose a Lambda? Well, the first big one is that only pay for what you use, aka scale to zero, aka 100% utilization. This is a fancy way of saying that it's stateless and on demand, and the process goes away when you're done. Lambda also has comprehensive language support. You can use Node, you can use Python, Ruby, Go, whatever, .NET, you name it. Logging and monitoring built in. It's extremely secure. It has both a thing called IAM as well as a Firecracker sandbox. It's very fast. There is rumors of a cold start being a problem, but those rumors are untrue. You can cold start sub-second in almost all cases. So this is not truly an issue unless you need to be faster than sub-second, which most of these cases you do not. And there are ways around it. Things like CDNs help. And it's deterministic. You can deploy with a thing called inference code and CloudFormation, which means you get the same deploy every time, no matter what happens. So that's a big deal. That helps your velocity. So next big problem we have, okay, I adopted Lambda. Well, what problems did that create? Well, one of the big problems with Lambda is that it supports over 270 services. So, what do I wire this Lambda function up to? But we got to remember, we're building a web app, right? We're building this web app, and we're probably building a dynamic database-backed web app. We're going to have a database, we're going to talk to it, we're going to load stuff dynamically through an API probably. And that actually helps us really narrow the field. So let's dig into that. Like, what capabilities do we need to build a web app? Well, we're going to need HTTP. We're going to need to talk to the internet, and we're going to need possibly WebSocket support. We're going to want queues. Now, queue is a construct that we'll use for throttling. So if I'm calling a third-party API and I can only make n requests per second, then the queue will let me throttle those requests down without having any bugs on either side. Very useful construct. We use them all the time in the background on the back end. There's another concept called events, pub sub. Sometimes it's a push primitive that we use for fanning out lots of messages to lots of subscribers. It's a very handy thing that we're going to need. Sometimes you just need to schedule a background job. Sometimes we call these cron jobs. It's when you have a function that runs on some form of schedule. If we're building a web app, we're going to need static assets. And if we're building a web app, we're going to need a database. And what's wonderful about taking this stuff and really putting these use cases up front is it gives us a way to really narrow down the field and see what services that we need from Amazon. So if we need HTTP, we need API gateway. If we need queues, we need SQS. If we need events, we need SNS. If we want to do cron tabs, we're going to do EventBridge. S3 is the original serverless primitive, which will help us deploy static assets. And then, in my view, DynamoDB is the database to choose if you want to go completely on demand. So that's 6 services. That's actually not bad, right? That's not 270. It's pretty easy for us to parse. There are more than that though, like Lambda as a service, and I use Route 53 for my DNS, and probably going to want CloudFront for a CDN. We know that Lambda comes with IAM built in for security, so that's something we're going to have to learn a little bit about. And it also works with another service called CloudWatch for logging and monitoring. And if we want this deploy to be deterministic, we'll use CloudFormation for inference code. Okay, so you got me, 12 services. Still a lot better than 270, easier to parse, but how do we think about these is also important because it's going to help us compose these into other things. And when you look at the various clouds, most of them break things up by compute, storage, network, and governance. These are high-level ideas or high-level groupings for our deployments, and almost all apps have these capabilities. And when we bust out those services and start looking at them through this lens, we'll notice that there's a very big difference in life cycle between these. You don't change your DNS every day, but you do change your code for your app every day. You don't change your database tables, and you don't really change, a lot of this stuff. The storage, networking, and governance is quite stable in the life cycle. It doesn't get deployed as often. And only 5 are concerned with compute. And really, of those 5, only 4 are event services, and the compute model is Lambda. So, when we step back and we really look at this, a database-backed web app that has on-demand scaling with no real overhead or upper bound limit is only requires 12 services out of 240, and only 4 of those are for the back end. Like 4 primitives total, 4 for all of your backend logic. You need HTTP, you need queues, events, schedule, and you're good. So that makes Amazon a lot less hard. It's a really nice way for us to step back and see how this can be put in a much easier context to work with. The next issue here is that AWS trades consistency for velocity, and it does make it complex. All my business logic might sit in those 4 services, but those 4 services are going to require a lot of glue to get them together. How do we glue these things together? I mean, how am I supposed to compose this? How do I deploy it? What does packaging look like? And this is where a framework is going to come in to the story. A framework's going to bring you consistency, it's going to bring you conventions, and it's going to bring you community that's going to help you figure this stuff out. And once again, our problem or our solution comes with a problem. And that problem is, okay, well, now I need a framework. What framework am I going to choose? And this one's loaded. We all know this one's loaded. How do you judge what framework you need? A lot of people think that the best selection criteria is how many GitHub stars it has. But I would like to invite the audience to consider that there might be a better way to consider how you evaluate your selection criteria for a framework that you're going to choose. I went through this exercise a few years ago myself, and I knew that one thing that was important to me is that it should be easy to get started. It should be open source and have an active community, and ideally open governance, so that if I want to contribute back, I can. If something's going to go wrong, which it will, there's a place to file a bug, and the process for getting that bug fixed isn't going to be a black hole. It needs to support CloudFormation. This is table stakes these days. So CloudFormation is a tool called for infrastructure as code. Heard me mention it a couple times. A high-level idea of infrastructure as code is that you have a lock file that names the cloud resources you name. And so when you deploy, you get those cloud resources. It's very similar to how dependency management works in the node world. And dependency management, I have a file and I say, I need these dependencies, and NPM is going to make sure that those are there. CloudFormation is the same idea for the cloud. Say, I need these dependencies to be there when I deploy, and they will be there. So you can't really build an app at scale these days without infrastructure as code, not consistently, not with determinism and speed. And we want those things. CloudFormation is the first class way to do this at AWS. So this is the way that you're going to want to do it. And it's got to support local development. And this is a controversial one. Sometimes people get a little bent out of shape about this. I don't care who you are. You need sort feedback loops. You need to be able to work locally. You need to be able to work with mocks. Now, I'm not suggesting that we're going to mock out the semantics of the cloud locally. I'm suggesting that we can mock out the API signatures and emulate the experience of the cloud, so you can see if it's even working at all, let alone if the semantics work on a larger scale. Now, sometimes people say that you can't do this because things change. Earlier, we already discussed this, but Amazon doesn't change. They are very good at backwards compatibility. They don't want to invite you to evaluate a competitor. They want you to stick around. So they're very easy to mock, and they're very stable to mock against. And this is an important thing because your developer feedback loops need to be fast. And if I look at the available frameworks that are out there, not a lot of them really meet this criteria. Many of the popular JavaScript-y based ones like Next.js or Pulumi or even HashiCorp's Terraform and serverless all use API calls, SDK calls. They don't use CloudFormation in the hood, so they're immediately striked off the list as far as I'm concerned. You can debate with me about that in the Q&A later. CDK and Amplify are pretty interesting offerings. CDK doesn't have a local dev story, and it's not declarative, so it's not for me. And Amplify is very front-end centric. It doesn't really have a local dev story either. It does a little bit. AWS SAM is getting there. SAM stands for Serverless Application Model. It's an extension on CloudFormation that makes writing CloudFormation a little bit nicer. It's not easier to get started, and unfortunately not open governance, but it does hit all these other points. Local dev's a bit dodgy, honestly, but it does sort of work. And there's a fix. And I'm sure this will surprise no one because it's a fix I'm a maintainer of. OpenJS Architect, we have open governance. We are very easy to get started and support CloudFormation directly and local development. And so with that, I'm going to get into a little demo here where I'm going to show you how we build stuff. And so if you want to follow along at home, you can. npm install global architect. You will have all the tools to do what I do. Just going to do a very quick switcheroo on my screen share here. And let me hop over to my terminal. Can you all see that okay? I'm hoping so. Okay, so I'm going to jump to my desktop and I'm going to make a directory and I'll call it city.js. I'll hop into city.js and I'm going to run npm init. That's just going to create a package JSON file real quick. And I'll quickly install architect functions into that repo. And while it's doing that business, I'll just open this up in another terminal. And we can see that there's not much going on here. It's just a package JSON file. And and nothing else. So I'm going to get rid of some of this junk just to make it easier to read. I'm going to add a key called arc. And under arc, I'm going to have an app key. Yeah, and an HTTP key. Now this is infrastructure as code. And I'm going to have, what I'm saying here is I need API gateway. Oops. And I'm going to map it to the root of this project, method, any. So any request to this project, load this source. And I'm going to add an index.js. Say function HTTP request. We'll return a response. Status code of 2 hundo. Headers. Content type. Text HTML. And oops. We'll just do a really cheesy body here. Hello world. We'll know it's working because we'll italicize world. See my awful HTML. We'll run arc sandbox. That's going to kick a local sandbox. And we'll hop over. Oh, probably can't see that. 1 second. Let me reshare my desktop. And you can see, over here that we got our little hello world. And so we're working locally. Happy days. Not too bad. No servers involved. Just a function with 0 dependencies and a package JSON file with this arc key. Now I have this little helper here, arc functions, that I installed, and I'm going to use it. It's going to make this a little nicer. So we'll require that in. Ooh, arc functions. And actually, I want to grab HTTP out of this, so I'm just going to do that. My function over here is named HTTP, so I'm going to rename that to handler. And now we can go http.async. We're going to pass it handler. Now all this junk can go away. And we can just return. That is functionally equivalent. So not all that exciting, but a little less boilerplate than before. And it'll quickly become apparent why we want to do that. The default payloads that you get from Lambda are actually pretty ugly. You want some kind of middleware interface, and we build that in for you. This is a pretty trivial, simple app. So maybe we can make this a bit more interesting. But before we do that, I'm going to quickly deploy it. So that's one command. Set anything else up. Too big of a deal. I do have AWS creds on my machine, and that is admittedly some work. But this is, 2 commands, and you're able to build something locally and deploy it up to the cloud. This will take about 1.5 minutes the first time, and about 37 to 30 seconds every time after that. And every time that you deploy this, we're creating a CloudFormation document under the hood. So this little bit of infrastructure as code that we put inside of, oops, oh, my mouse isn't working. That's okay. Well, I imagine it'll come back after our deploy is done here. Actually, maybe I could cheat. We'll go over to this one. So that's kind of fun. You can see the generated CloudFormation here, which is kind of nice. And oh, interesting. My package JSON is not there anymore. It's like I deleted it. A mistake, but my app just deployed and it still works. So that's good news. Where did my package JSON go? That's kind of sad. I guess I'll have to rebuild it. That's okay. So let's do that. npm init-f. I was going to rebuild it anyways. And let's go look at it. And, oh, wow, we got a whole bunch of stuff here, but that's okay. And we're going to quickly get rid of, well, let's do npm I architect functions first. And see that we got it, which is nice. Don't need all that. Don't need that. Don't need that. Don't need that. Okay. So you can add arc or architect. Both are going to work just fine. And we're only defining API gateway right now. So I'm just going to quickly show you defining a couple of functions. So we have slash responding to method any, and source is here. And I could actually, well, let's just save that. We'll restart it and test it locally very quickly. Oh, I know what happened. I'm running it in a sandbox over here, aren't I? The demo gods have been unkind. What did I do? Break myself? Oh, app name's not found. That's right. Got to give it an app name. And the reason why is because we prefix everything with that. At some point, we're probably going to bring it over to here and use that, but haven't done that yet. Anyways, good error. Told me what was wrong. I was able to fix it. Happy days. I'm back to my hello world. All right. I'm running low on time. So I really wanted to show you session support. So I'm going to do it, but I've got to hurry. So if I were to look at the inspect the request that's being made here, I could get all the variables out of it from AWS. So let's quickly do that. We're going to do the poor man's debugger, and I'm sure you've all done this before yourselves. Go back here, we see a formatted. Now this was the payload that came in. And a part of that payload you'll see is session. And you can see me working on my demo earlier. There's already a session for this browser, which is pretty funny. And it's showing count. So we could just drop that right here. Request.session.count. We reload it. Let's see, hello 3, which is kind of neat. So count, request.session.count, or it's 0. If request.method equals post, do count plus 1. Now we got to add a form for posting. And this is going to be shockingly easy to do. Form, action equals slash, method equals post. Ah. Let's reload that page. It's no longer this thing. Now there's just this send. Oh, I didn't get my post. So I am posting. Maybe it's not request.method. That's what I get for turbo coding my way through this. JSON.stringify. Request null 2. Send that post. Oh, it's undefined. Oh. Great. And if I post, body should have had some value, but it didn't. And does it have a method? It did. Oh, I know why. I know why. Because I didn't write to the session. I got nervous. I was giving my talk. Right here, I want to return session count. application /. So it's going to redirect us back home, rewriting the session. This should work this time. You can see it posted and I got a 4. So if I hit send again, it should be 5, 6, and you get the idea. So instead of stopping sharing, I'll stop over here. Bump you up. So that's a quick idea of Architect. We don't just support API Gateway, we support all of the primitives that I had mentioned earlier. So you can do WebSockets with Lambdas, you can do queues, you can do push events, you can do cron tasks, support DynamoDB out of the box, and of course S3, so you can use whatever front-end framework you want, and lots of people do. And if you still find working with AWS a little bit weird and intimidating, you can try out begin.com, where we make this 2 clicks. You can build Architect apps in literally 7 to 30 seconds. You can find all the source code on Architect, and you can find me on Twitter way too often, and I'm always happy to chat about this stuff. So thanks for having me, and I will be available in QA land.
Brian, what a brilliant talk. Thank you very much for sharing some of your wisdom around the fast stack with the CityJS audience. I'm sure everybody took a lot away from that, particularly if they are using the AWS stack. Please join me in giving Brian a huge round the world round of applause. Our Q&A session with Brian will be starting on GatherTown any moment now, so head on over there if you have any questions about the fast stack for Brian. Failing that, post along on social media using the hashtag CityJS2021 or on YouTube using the comments section.
Brian, welcome to the CityJS QAs. How did you find that talk?
It was fun. I was panicking a little bit at the end there, live coding, you know, always gives me a bit of an edge, but I deployed a thing to Amazon and built it from scratch. And I don't think I swore very much. If I did, I'm sorry.
No, it's all right. We assume we're all grown-ups here. We assume at least. So fantastic talk. We've had a question come in already, so we can dive straight into that.
Sure.
Earlier, we had a talk about taking back control, and it's kind of been a theme of the conference so far, a subtle theme. How do you guard against outages on Amazon's infrastructure when using this kind of stack? Is there anything you can do?
Yeah, there's a few things. I mean, one thing you have to know is that there's always going to be a shared responsibility for uptime and security, and stuff goes down. That's inevitable. There's no cloud that doesn't suffer outages or issues. And so you do have to build fairly resilient. We ourselves were lucky in the last Amazon outage back in November. US East 1 basically wasn't out, but it was experiencing increased error rates, which cascaded through the system. I think Kinesis went down and that took out Cognito and it took out other services. And a lot of people were saying, oh, you know, good on you for not deploying in US East 1. That's why you didn't go down. And that's not true. It is true that I don't deploy in US East 1 because it tends to be where the new stuff comes out and there's problems, but you can't avoid this. So like US East 1 is also where IAM is and other global services like Route 53. So like really it's a dice throw. And ultimately you just have to ask yourself which provider do you think is going to be the most stable? The market leader and Pioneer or another player who's competing with them?
I mean, there's no argument with that, really, is there?
It's not really. No, I mean, they've got the most data centers, the most experience, the most people, the most capabilities, and they still go down. And I think that's actually, in somewhat of a way, a little bit reassuring. If Amazon had no bugs at all and no issues, then I'd be terrified even more of them.
Yeah,
just
I'd be asking,
I guess the TLDR is shit happens, and you got to be ready for it. And you know, you will have downtime. You're going to have it, and you're going to have to deal with it with your customers, and you're going to have to explain to them what happened, and you're going to have to make it right. It's going to happen, and it's better to plan for it instead of hoping it doesn't happen.
That a truer word has never been spoken than that, but planning for it can be quite tricky, I guess, especially if you're new to this stuff. If you're new to serverless and everything else that Amazon offer, as you
Yeah,
touched on in your talk, knowing what to pick is one thing, but knowing how to mitigate outages for that thing you've picked.
yeah. I never say never, but I don't think we're going to see major outages for things like the default of Lambdas are to be off. They only turn on when you request them. So it's a whole new stateless model, and it is a bit weird to work on. But once a year or so, there's an issue, and we have to reach out to customers as much as they do too. One thing I really appreciate about Amazon is they tend to own this stuff. So like when they have an issue, there's really, really good support during and after. And really, it's only gotten better over the years.
Oh, that's good to hear. I think this is a follow-up question. Multi-cloud is no option for you?
It is. I think the problem is the marketing departments are a little bit ahead of the engineering departments in the other clouds. So they make a lot of claims that they just can't cash as far as the checks go. So very, very low level basic building block for me is infrastructure as code. I want to be able to define my cloud resources in a document of some kind. And then when I get a deployment, I get the same thing every time. Azure has a thing called ARM, but you still have to use SDK calls to augment it. GCP doesn't even have this concept, so people use Terraform. I mean, that's table stakes. So like right there out of the gate, they're already not really an option as far as I'm concerned. I anticipate that AWS's leadership will diminish over time, and we're going to see more consolidation, and we're going to see more de facto adoption of these patterns. And Azure is quickly copying a lot of the stuff they do. The other reason to be bullish on Azure is they've got GitHub, they've got Visual Studio Code, and they've got TypeScript. They basically have the developers, in their pocket. So eventually they're going to have a button that says deploy to Azure, and you're going to use it. So I'm keeping a hairy eyeball on them. I wouldn't give them as much credit as they give themselves currently for what they can do. No. I make some pretty big claims, like I promise you can deploy in 30 seconds. I promise that, you can scale infinitely. I promise that you, will be able to have a query to your Dynamo table that will return within single digit millisecond latency, no matter how many rows you have. I can't make any of those claims if I go multi-cloud. And to me, the onus is on them to let us build this way. And they're very aware of how far behind they are. And they're just compensating with marketing at the moment.
Okay. And I think the service you offer is, well, to be honest, when I looked at the website, I thought, nah, they can't do this. These are some big claims. And
they are. Yeah. And I invite people to verify it all for themselves. And the source code's all open. So, you can deploy these things and check it out for yourself, how we built it. It's not to say that it's not without having to rethink things. When you approach the world from the previous lens, we think about monoliths and servers and rolling deploys where I put a server up and I take one down, I put another one up and I take another one down. On serverless, I upload a zip file and next request, it's available. And if I have 1,000 functions, it takes the same amount of time as if I have one, because I can deploy them in parallel. I'm not waiting for each one to go up at one after another. It's just an entirely different model. We're used to uptime being important, and now uptime to me is a negative metric. I want to pay more money for stuff I'm not using. That's not a good idea. And what is a server anyways? Not racking things. I'm writing functions, right? So to me, this is just like an inevitability, and we're all going to arrive there at some point.
I wouldn't disagree with you. And that leads me lovely onto a question of my own, actually. I was talking to one of my mentees not too long ago, and they're just starting out in the industry. And I mean, just starting out. They've just got the basics of code going. And we're starting to
that must be so fun.
It is. It's really fun working with him as well. It's brilliant to see the excitement in his eyes when he gets
no cynicism. Yeah, totally.
And we were talking about how we're going to get his code online, and I kind of suggested serverless without thinking about it in too much. Do you think there's an argument to be made that when teaching new people to the industry, that we should be teaching them serverless first rather than a whole load of Linux server management stuff before they can even get the code going?
Yeah. I mean, there's the biased answer here. As a business owner that deploys to AWS serverlessly, I'm going to say everyone should do serverless. But I think there's value in understanding how we got here. I think there's lessons to be learned and understood. I recently picked up this book. It was I don't think I have it around me, but it was supposed to be about Node. And 5, 6 of the first chapters are about Kubernetes and deploying it and all this. And I'm just like, what is this? This is like, I don't need to do any of that to scale, like really. So I think from a progressive disclosure perspective, it might be better to ease them into here's HTTP and functions that return, headers and stuff, and learn the high level. And then if they should need to go deeper, they will have a wealth of stuff to get into later.
Yeah.
And it's a tough one because there's no wrong answers here, right? Like, and I can't stand a vendor who's like, my way is the only way. Like, I'm not going to be that guy. There are reasons to not do serverless. If you need a low latency, long-lived workload, you might need to run some servers, and it's not going to be the end of the world. If you just got started in this industry, that is a pretty big ask. You got to learn about IP tables, and DNS, and routing, and all this other stuff that maybe doesn't matter. And it depends on the kind of like what they want to learn and do too. I think from a career perspective, if you become a badass at Amazon's serverless stack, you're very employable. I think from like, you're going to have, everybody needs that person right now. If you've just done what everybody else does, well, there's lots of those, right? So there's that argument too.
So if you're listening along, Liam, I'm sorry, we're going to go the long way.
Yeah, and I think that's all right, because you'll appreciate the serverless stuff a little more if you've load balanced a monolith. Like, go get Beanstalk spun up and make a change. Go for a coffee, come back, it's still not changed. And then deploy a Lambda function, make a change. Literally 6 or 7 seconds later, you see the result. So there is a feedback loop thing there, and yeah, I don't know. It's a good one, because I do think developers are well served by going low and understanding the stuff they're building on.
Definitely. We are coming to the end of our Q&A time, but we've just had a really, really good question come in, which I don't have time to go into. So I wonder if after you finished here, you can go into GatherTown, find that in the conversation and answer. It came, I don't know who it came from, but I want to know the answer. So do please go and do it.
I'll jump into Gather for sure. Yeah.
I've got a couple of quick fire questions to round us off. We're doing a survey of the developer ecosystem at the moment, and we start with the most important question: tabs or spaces?
Spaces. 2.
Good. 2 spaces. You get 2 ticks for that.
Yeah.
Front end or back end?
I think front end's winning, and I think what I just showed was the path for the front end to go take that gate and own the back end. So these things are becoming very nebulous. Like, building front to back now is getting really mixed up. So I'm always going to go for the web developer on this one, front end.
Okay. And finally, apples or bananas?
Oh, it depends. I don't know. Shit.
It's the big one, I know.
I like it. Banana cream pie, but I like an apple. I don't know. Bananas.
Bananas. Brilliant. On that note, we're going to leave it there, Brian. Thank you very much for being a part of this year's conference. We really appreciate the time you took in crafting an excellent talk, plus the 30 seconds it took you to deploy and build the application.
Thank you.
It was a minute. It was a minute, wasn't it? Sorry about that.
Yeah, it was around there. Yeah.
Thank you very much. And if you're watching along at home, please do make sure you check out the sponsor boost before you head off and win some competition prizes, hopefully. Brian, thank you.
Thank you.